Hello everyone, welcome to our presentation on ANOVA two-factor with replication. We are from Group 1 Industrial Engineering Class 2 from the material of Statistic 1. Today, we will be explaining the concept, purpose, calculation, and example of two-factor ANOVA with replication, one of the most essential tools in inferential statistics. This test help us to understand how two categorical factor influence a continuous variable and whether these two factors interact with each other. So, let's begin our discussion. Okay, before we start, let's introduce our team member. Our group consists of me, Bill Christian Panjaitan, and the second is Putri Lasrida Malau, and the third is Elizabeth Kurniawan, and the last is Regina Vinta. Together, we have prepared this presentation to make sure the concept of ANOVA two-factor with replication is easy to understand and practical to apply. Okay, ANOVA. What is ANOVA? ANOVA stands for Analysis of Variance. It's a family of statistical technique used to compare mean across multiple groups and determine whether the observed differences are statistically significant or just due to random variation. Instead of comparing means directly like in t-test, ANOVA examines the variance both within group and between group. If the variance between group is much larger than the variance within group, it suggests that the independent variable or factor has a real effect on the dependent variable. In simple terms, ANOVA helps us figure out if the group difference we see are meaningful or not. Okay, next, we talk about the purpose of ANOVA. The purpose of ANOVA can be summarized in three main points. The first, it helps us test whether the means of several groups differ significantly. And the second, it controls the type I error which happen when we incorrectly say there is a difference while in fact there isn't, especially when comparing more than two means. And the third, ANOVA allows us to analyze how one or more categorical factors influence a continuous variable such as performance, score, or output. Because of these three reasons, ANOVA is widely used in experiments, business, psychology, and engineering research. Okay, next we talk about the types of ANOVA. There are several types of ANOVA depending on the design of the study. There is one-way ANOVA is used when we have one independent variable or factor, and also two-way ANOVA is used when we have two factor, and two-factor ANOVA with replication, which is our focus today, is used when we have two factors and more than one observation for each combination of those factors. There is also repeated measures ANOVA used when the same subjects are measured multiple times, and MANOVA, which stands for multivariate ANOVA, used when we have more than one dependent variable.
So, what is two-factor ANOVA with replication? It is a statistical technique used to evaluate the influence of two categorical independent variables, called factor, and their interaction on a quantitative dependent variable. The with replication part means there are multiple observations for each combination of factor levels. For example, if we're testing how teaching method and student gender affect exam scores, and we have several students for each combination, we can apply two-factor ANOVA with replication. In this method, we look at the three different factors. First, the main effect of factor A to see whether the dependent variable differs across the levels of factor A. 2. The main effect of factor B to see whether the dependent variable differs across the levels of factor B. 3. The interaction of effect A times B to determine whether the effect of one factor depends on the level of another. If the interaction is significant, it means that the influence of one factor cannot be interpreted without considering the other factor. We use two-factor ANOVA with replication when these conditions are met. We have two categorical independent variables. We have a quantitative dependent variables like exam scores or output rate. each combination of factor levels, called a cell, has more than one observation, meaning replication exists. We want to test both main effects and the interaction effects between the two factors. When all these conditions are satisfied, this method is the right choice. This is how we can solve the two-factor ANOVA. The procedure of two-factor ANOVA with replication can be divided into 5 steps. First, state the hypothesis. Step 2, compute the sum of squares. Step 3, compute the F ratios. Step 4, make the decision. And step 5, draw the conclusion. So let's go through each step one by one. Step 1, stating the hypothesis. In this test, we have 3 sets of hypotheses. For factor A, H0A, there is no significant difference among the means of factor A. For factor B, there is no significant difference among the means of factor B. For the interaction, there is no interaction effect between factor A and factor B. Each of these hypotheses will be tested using the F statistics. Step 2, computing the sum of squares. The second step is to calculate the sum of squares, which represents the variability in the data. We calculate SSA, the sum of squares for factor A, variability due to difference among level of factor A, SSB, sum of squares for factor B, variability due to difference among levels of factor B, SSAB, sums of square of interaction, variability due to combined effect of both factors, SSE, sum of squares for error, the unexplained or random variation. The total variability, called SST, equals the sum of all these components. Each component is divided by its degree of freedom to obtain the mean square.
Next is compute the F ratios. Once we have the mean squares, we can calculate the F ratios using the formula F equal MS factor divided by MS error. We compute one F value for factor A, one for factor B, and one for the interaction A multiply B. Then we compare its calculate F value with the critical F value from the F distribution table or use the P value from Excel. If the F value is greater than critical value, we reject the null hypothesis. Next is step 4, which is decision making. In this step, we decide whether to accept or reject the hypothesis. First, if the calculate F value is greater than critical F value, we reject the null hypothesis for that factor. And second, if it's smaller, we fail to reject the null hypothesis. For example, if factor A is significant, the teaching method influences performance. If factor B is significant, gender affects performance. If the interaction is significant, the effect of teaching method depends on gender. For instance, one method might work better for males than females. Step 5 is conclusion. Finally, we summarize the results. We check which factors are significant or interpret their meanings. This helps us understand whether the observed differences are due to actual effect or just random variation. Next is example. Let's look at a practical example. A researcher wants to study how different teaching methods and student gender influence academic performance in mathematics. Factor A is teaching method with 3 levels: traditional lecture, interactive discussion, and online learning. Factor B is gender with 2 levels, male and female. The dependent variable is the student final exam scores. To increase accuracy, the researchers collect data from 5 students in each group, meaning there are replications. Altogether, the total number of data points is 3 teaching methods multiply 2 genders multiply 5 students equals to 30 observations. And then this data will be entered into Excel for analysis.
Now, let's see how to solve this example using Microsoft Excel. First, enter all the data into the spreadsheet clearly, separating each group by teaching method and gender. Then, click the Data tab on the top menu. Choose Data Analysis from the right-hand side. From the list, select ANOVA 2-factor with replication and click OK. Next, make sure to highlight all the data for the input range. In the box labeled rows per sample, type 3, since there are 3 teaching methods. After that, click OK, and Excel will automatically generate the ANOVA output table showing F values, P values, and critical F values. This result will help us make our statistical decision in the next step. Now let's take a look at the result produced by Excel. The ANOVA output table showed 3 main sources of variation. The first one is gender or factor B, the second one is teaching method or factor A, and the last one is interaction or A times B. For gender, the value is 2.486 and the p-values is 0.13, which is greater than 0.05. This means there is no significant difference in exam scores between male and female students. For teaching method, the F value is 191.527 with a p-value of 0.94, which is also higher than 0.05. This means the 3 teaching methods do not produce significantly different results. Finally, for the interaction between gender and teaching method, the F value is 34.247 with a p-value of 0.99, still greater than 0.05. So overall, since all p-values are above 0.05, we fail to reject all null hypotheses. This means neither gender nor teaching method nor their interaction has a significant effect on the student performance in the study. So for our decision summary, the first one is there is no significant difference between male and female student score. And the second one, there is no significant difference among the 3 teaching methods. And the last one, there is no significant interaction between teaching method and gender. Therefore, the teaching method and gender do not meaningfully affect the result. For our conclusion, based on the ANOVA output, all p-values are greater than 0.05. This indicates that neither gender nor teaching method significantly influence exam scores. There is also no interaction effect, meaning that teaching method performs similarly across genders. Hence, we conclude that the observed differences are likely caused by random variation, not by the factor tested. So that's all for our presentation. Thank you very much for your attention and also your time. We hope our explanation help you understand how to perform and interpret ANOVA two-factor with replication. Once again, thank you and have a great day.